everyone, welcome you all to the chemistry class. In the previous sessions, we have discussed about the chapters chemical reactions and equations and acids, bases and salts. And in the today's session, we are going to start with the chapter metals and non-metals. So, my dear students, in this chapter, we are going to study the physical properties of metals and non-metals, chemical properties of metals and non-metals, and we also study the reaction of metals with non-metals. Then we will also be studying the ionic compounds and how are they formed, and also we will study the properties of ionic compounds there. Then we will come across the extraction of metals from their ores. Then we will study the refining of metals, and also we will be studying the corrosion and its preventive measures. So these are all the concepts that you will come across in this chapter. Okay, we know that the elements which are occurring, they are classified into metals, non-metals and metalloids. Based on their physical and chemical properties, elements are classified into metals, non-metals and metalloids. These metalloids are having the properties in between metals and non-metals. So, when you see the periodic table, most of the area of the periodic table is covered by metals. So there are plenty of metals around us, which we will also see in our daily life. We have applications of metals and non-metals in our daily life. You can see here, these are some of the materials or the things that you see in your daily life. Yes, cars, buses, jewelry, crackers, homes, fertilizers, all these materials consist of either metals or non-metals. Yes, can we check here what do cars and buses are made up of? They contain the metal, mainly iron, steel. Yes, steel consists of mainly the iron. Then jewelry, what it is made up of? It is made up of gold, silver and platinum. Yes, then what do crackers are made up of? They are containing phosphorus in them. Phosphorus is a non-metal. Then we know that our homes, buildings, bridges, they are all constructed by using iron as the main material because it is the hard substance and it is having the good tensile strength. Then what about fertilizer? It consists of the non-metal nitrogen. Then fuel, carbon is used as fuel. You can see in the charcoal, it is mainly carbon there. And when you see the coins, they are also made up of metals. And in the olden times, we hear that the coins were made up of purely silver, gold, etc. The expensive metals were used to make the coins in olden times. And we will see that utensils that we use in our kitchen are made up of steel, which consists of iron, and aluminium, copper. These are the metals which are used in making the utensils. Have you seen the thermometer? What it consists of? It consists of mercury, which is a liquid metal. Then many furnitures, tables, stands, they are also made up of many metals. Mainly they consist of iron. Okay. Then when it comes to electricity, the electric wires are made up of copper and aluminium, as they are good conductors of electricity. Then aeroplane, it is a vehicle which is mainly made up of aluminium. Okay, these are some of the applications that we see in our daily life about the metals and non-metals. So let us study how the properties of these metals and non-metals are important. Okay, let us move to their properties now. Yes, can you remember the physical properties of metals that you have studied in the grade 8? Yes, we have already studied that they are solid, they are hard, they are good conductors of heat and electricity and all. Okay, let us recall them one by one. We know that all the metals are solid at room temperature. Yes, we know that all the metals, they are solid, like iron, copper, cobalt, nickel. Yes, these are all solids at room temperature. Gold, silver, platinum, these are all metals which are solid at room temperature. But except mercury. Mercury is the only metal which is liquid in state. Okay, you have to remember the exception because it will be asked in your examination also. Okay, whenever there are exceptions in their properties, please do remember. Okay, and metals are hard because of which they are widely used in the construction purposes also. Yes, they have high melting point. We know that melting point, it is a temperature at which the substance melts. Okay, but these metals are having high melting point. So we will use these metals in our daily life purposes, like in kitchen also we use the utensils made up of metals as they are having high melting point. If you heat iron for a longer time, nothing will happen, it will not get melted because it is having high melting point. So we do use iron, copper utensils in our home. But you should remember that among these metals, only the gallium and cesium, these are the metals which are having low melting point. They have such a low melting point that they even melt if you keep them on your palm. Okay, these are the only two metals which are having low melting point. You should remember these exceptions. Then metals are lustrous. What do you mean by lustrous? Means they have shining surface. They are having shining surface. So you can see that the jewelry are made up of usually the gold and gold, silver and platinum, because they have very shiny appearance and they look very beautiful. Then metals are malleable. Malleable is such a very good properties of metals that they can be beaten into thin sheets. Malleability means it is the property by which metals can be beaten into thin sheets. You can see that aluminum foils are available nowadays because this aluminum metal is malleable. If you take the metals like aluminum and hit it with a hammer, what happens? They will not break. They will form the thin sheets. So such property is used in making the materials like sheets. Okay. Then metals are ductile. Ductile is also, ductility is also a properties of metals that they can be drawn into thin wires. Okay. Ductility, it is a property that they can be drawn into thin wires. Have you seen the wires, that is electrical wires? It consists of the copper. Yes, copper wires, very thin copper wires will be there. As they are good conductor of electricity, it is used in the electrical equipments there. In that you can see that copper is drawn into very very thin wires, and into many longest distances also it can be drawn into wires. Okay, this is a property called as ductility. Then they are good conductors of heat. Yes, metals are good conductors of heat. Among them, copper and silver, they are the best conductors of heat. Have you seen in the kitchen that the steel utensils are covered with the copper at their bottom? They are called as copper bottom utensils. Yes, there is a coating of copper at the bottom of the steel utensils there. Why is the necessary of coating the copper at the bottom of those utensils? Because it is a good conductor of heat. So it is used in making the utensils. And silver is also the best conductor of heat, but we will not use the coating of silver because it is a very expensive. Then but there are some exceptions, like poor conductors are lead and mercury. We know that they are good conductors of heat, that is metals, but among the metals, these two, that is lead and mercury, these are bad conductors, that is they are poor conductors of electricity. Then all the metals are, except these two, all the metals are good conductors of electricity, because of which we know that copper and aluminium are used in the electrical circuits for connections purposes. Then one more important property is metals are sonorous. Sonorous is a property that when you hit or when you strike the metals with the hard surface, they will produce a special kind of sound, that is ringing sound. You might have seen in your school days, that is in your school, that they produce a ringing sound. Yes, that is called as sonorous. So metals are sonorous in nature. Okay, this is all about the physical properties of metals, but it is important that you should remember the exceptions. That is, mercury is the only metal which is liquid in state, and among the metal, which two metals are having low melting point, that is gallium and cesium. And though metals are good conductors of heat, lead and mercury are the poor conductors. Okay, you should remember these properties. Then let us move to the next, physical properties of non-metals. Almost all the properties, they are opposite in nature when it comes to non-metals. See here, non-metals, they may be solids, liquids or gases. Solids like phosphorus, it is solid non-metal, or sulfur or carbon, they are solid non-metals. Liquid means bromine is the only one non-metal which is in liquid state. Okay, and gases are many like hydrogen, nitrogen. oxygen. These are all non-metals which are gases in state. So they may be either solid, liquid or gaseous. And remember that bromine is the only non-metal which is liquid in state. Okay, and non-metals, they are not usually hard, they are brittle, means they can be easily broken, and also they are not malleable and ductile. They will not form any thin sheets or they cannot be drawn into wires because they are brittle in nature. And remember that diamond, it is the hardest natural substance. Even though non-metals are brittle, means they are not hard. Among them, diamond. What is diamond? It is an allotrope of carbon. Carbon has allotrope. Among the allotropes, it is having graphite, diamond. Allotropes means when the elements exists in two or more different structural forms, they are called as allotropes. Okay, here diamond and graphites are the two allotropes of carbon. Only difference is in the geometrical structure, how the atoms are arranged. Okay. Then non-metals are not lustrous, means they are not having shining surface, but except iodine, these iodine crystals are lustrous. You should remember the exceptions. Then non-metals are not malleable and ductile. As we know that they are brittle, because of which they are not usually malleable and ductile. They cannot be formed into thin sheets or drawn into wires. Then non-metals have low melting and boiling points, and they are bad conductors of heat. They do not conduct heat. Then they are bad conductors of electricity, except graphite. Graphite is the only non-metals, means graphite is nothing but it is an allotrope of carbon. As we know, it is allotrope of carbon. It is the only non-metals which conducts electricity. Then they are not sonorous, means they will not produce ringing sound. This is all about the physical properties of non-metals. You should remember some of the exceptions given here. Okay, so let us recall some of the exceptions here. Mercury is the only liquid metal. Gallium and cesium metals have low melting point. They are having very low melting point that they will melt even keeping them on the palms of a palms. Gallium and cesium metals have low melting point, means they are having very low melting point that even they melt on our palms. Iodine is a non-metal which is lustrous. Then diamond, which is an allotrope of carbon, is the hardest substance. Graphite, it is also an allotrope of carbon, but it is good conductor of electricity. It conducts electricity. Then metals are usually hard, but the alkali metals, that is, which are lithium, potassium, and sodium, are so soft that they can be cut with knife. These are some exceptions which you have to remember. Okay. Next. Now let us start with the chemical properties of metals. First, let us start with the reaction of metals with oxygen. How do metals react with oxygen? Do you remember in the chapter 1 we have conducted the experiment of chemical reaction, that is between magnesium and oxygen. When magnesium was burnt in the presence of oxygen, there was formation of magnesium oxide, and magnesium burnt with a white dazzling flame. Yes, metals reacts with oxygen to form their respective oxide. What happens? Metals reacts with oxygen to form metal oxide. You can see many examples also. Copper reacts with oxygen to form black copper oxide. Yes, this is a copper oxide. It is an oxide of metal copper. Then magnesium also burns in the presence of oxygen to form magnesium oxide. So we can say that metals will react with oxygen to form metal oxides. When copper is burnt in the presence of oxygen, it forms copper oxide, and magnesium burns with a dazzling flame reacting with oxygen to form magnesium oxide. Also you can see aluminium will react with oxygen to form aluminium oxide. Balance the equation. Yes, this is aluminium oxide. This is copper oxide. This is magnesium oxide. So we can say that metals reacts with oxygen to form metal oxide. And also recall that you have studied metal oxides are basic in nature. Do you remember? We have studied in the previous chapter that metal oxides, they are basic in nature. That is copper oxide. We know that when it reacts with HCl, it forms CuCl2 plus H2O. That is salt and water. It is acid, sorry, copper oxide. So, copper oxide reacts with hydrochloric acid to form salt and water. These oxides of metal are basic in nature as they react with acids to form salt and water. You have studied it in the previous chapter. But there are some oxides of metals which will react with both metals with but there are oxides of metals such as aluminium and zinc which will react both with acids and bases to form salt and water. Okay, let us see the examples. This aluminium oxide is also such oxide which reacts with both acid and base to form salt and water. Let us see the examples. Usually metal oxides are basic in nature, but there are metal oxides which react with both to form salt and water. So understand this step by step. Okay, now we are studying that how do metals reacts with oxygen. We have come to know that metals will react with oxygen to form metal oxides, and also we have recalled that metal oxides are basic in nature. But you have to remember that there are some metal oxide which react with both acids and bases to form salt and water. Such metal oxides are called as amphoteric oxides. Such metal oxides are called amphoteric oxides. Examples of amphoteric oxides are aluminium oxide and zinc oxide. Okay, examples are aluminium oxide and zinc oxide. These are amphoteric oxides because they are not basic in nature, means they will react with both acids and bases to form salt and water. So they are called as amphoteric oxide. Okay, let us see how do they react with both acids and bases together. Okay, aluminium oxide is an amphoteric oxide. It will react with acid to form salt AlCl3 and water. This is salt and water. This shows that aluminium oxide is also basic in nature, and also it will react with base. Let us see how. It will also react with base, that is aluminium oxide, also react with base, that is sodium hydroxide, to form salt, that is sodium aluminate. This is sodium aluminate. Balance the equation. Okay, now we have seen that this oxide, aluminium oxide, is reacting both with acid and base to form salt and water. Yes, this shows that aluminium oxide is amphoteric oxide. You have to remember these names, aluminium oxide and zinc oxide. These are amphoteric oxides. And also you should remember the equation. How do these react with both acid and base to form salt and water. Okay, and some of the oxides of metals are soluble in water and they form alkalis. Most of the metal oxides are insoluble in water, but some oxides like sodium oxides and potassium oxide, they are soluble in water. Once they are dissolved in water, they form alkalis. Okay, sodium oxide, when it is dissolved in water, it forms alkali, that is sodium hydroxide. We know that alkalis are the bases which are soluble in water. Then also potassium oxide, it is also soluble in water to form potassium hydroxide. Okay, these are the metal oxides which are soluble in water to form alkalis. You should remember. Okay, some metal oxides are soluble in water and form alkalis. And the most important thing that you have to remember here is all the metals will not react with oxygen at the same rate. Different metals show different reactivity towards the oxygen. Yes, although it is right that they form metal oxides, but the rate of reaction or how they react with oxygen is different for different metals. Okay, let us see here. You can see the metals like sodium and potassium, they react very vigorously with oxygen so that they catch fire. Okay, react vigorously. They react so spontaneously with oxygen that they will catch fire with oxygen, that catch fire. So always we see that sodium and potassium are kept immersed in kerosene, because when it is exposed to the air, it may react with oxygen and it may catch fire, because of which sodium and potassium are always stored under kerosene. You should remember this fact. Okay, then this is about the metals. These are of which are of high reactivity. They react very vigorously in just a fraction of seconds to form metal oxides and they may also catch fire. And there are metals like aluminium, zinc, magnesium react slowly with air, means their reactivity is moderate, react slowly with oxygen at ordinary temperatures to form thin oxide layer. We see that these metals, they have upper layer which is covered with the oxide. For example, aluminium, when it is exposed to air, it forms a thin layer of aluminium oxide, so that it reacts very slowly with air to form their respective oxides. And once this oxide is formed, it is called as a protective layer. It will prevent further oxidation of the metal. Means once this layer is formed, that is oxide layer is formed, it will further prevent the oxidation of the metal. And we have come across the corrosion, yes, in the previous chapter. When these metals are exposed to air, they form their respective oxides. Yes, in the same way here we see aluminum, zinc, magnesium, when they are kept exposed to air, they slowly react with oxygen at ordinary temperature to form their respective oxides. And this forms the protective layer that it will prevent the further corrosion of those metals, means further they are not oxidized, as the thick layer of oxide is formed on those surface. Okay, then there are metals like gold, platinum, silver do not react with air, means they do not react with oxygen even at high temperature. So here we are observing that different metals have different reactivity. These two, sodium potassium, is reacting vigorously with oxygen even without heating. At ordinary temperature it will catch the fire. When it comes to the metals like aluminium, zinc, magnesium, iron, they react slowly with oxygen at ordinary temperature to form the thin oxide layer. And the metals like gold, platinum, silver, they do not react with oxygen present in air. Iron do not burn on heating, means it will not catch fire. But when iron filings are sprinkled over the flame, it will burn. But iron filings sprinkled over the flame burn. And copper will also not burn on heating. It forms a black layer, that is of copper oxide. Copper forms black copper oxide layer on heating due to reaction with oxygen. This is how different metals show different reactivity towards the oxygen. Iron do not burn in the presence of flame. It will not catch the fire. But when iron filings are sprinkled, it will burn. Then copper will also not burn on heating, but a thick or a black layer of copper is formed when it is heated. It is due to reaction of copper with the oxygen present in air. And you have seen that magnesium also burns in air with a dazzling flame to form magnesium oxide. This is how different metals will show different reactivity. Okay, you should remember this difference, how do these metals will react towards the oxygen. Okay, so we have seen that some of the metals like zinc, aluminium, magnesium, when they are exposed to oxygen present in air, they form thin oxide layer. Okay, they form thin oxide layer. Once the thin oxide layer is formed, it will prevent the further corrosion of metal. Okay, we know that corrosion is when there is a deterioration of metal, when it is exposed to air, there is a deterioration. This technique is used to prevent the corrosion of metal, that is called as anodizing. Let us see what is anodization here. For this, we will use the aluminium. How is the anodizing of aluminium is done? Let us see. Now we know that when aluminium forms a thin layer of aluminium oxide on its surface, then it forms a protective layer. It will not further react with oxygen to form aluminium oxide. That means it will not further undergoes corrosion. So this method can be applied to prevent the further corrosion of the metal. What we do is we will anodize the metal. We will take the tank. In it, we will take the dilute H2SO4. Dilute H2SO4. And we will keep here the electrodes, two electrodes. Here, anode is taken of aluminium. Okay, aluminium is anode here. The metal aluminium is made anode here. Once the electric current is passed through the solution, there is a liberation of oxygen at the anode here. At anode, what happens? There is a liberation of oxygen. Because this undergoes the electrolysis process, the water in it will be electrolyzed and the oxygen will be liberated at the anode. This liberated oxygen will react with aluminium to form aluminium oxide. Okay. The liberated oxygen reacts with aluminium to form aluminium oxide. What has happened here is aluminium reacts with oxygen to form aluminium oxide. Once this aluminium oxide is formed on this metal aluminium, it forms a protective layer. Means further the aluminium will not undergo any corrosion process, because of which the process of anodization is used. What is anodization or anodizing? It is a process of forming a thick layer of aluminium oxide on the aluminium metal prevent or to resist further corrosion. So once this thick layer is formed on the metal, it will not further undergoes the corrosion, because of which anodization process is used. And also it will resist the material from getting scratched, and also decorative look can be given after anodization. Okay, this is all about the reaction of metals with oxygen, and this is also the point that is important. You should remember why anodization is done and on which metal it is done. It is a process of forming a thick layer of aluminium oxide on the aluminium metal. Why it is done? It is done to prevent the further corrosion of the metal. Okay, let us discuss some questions here. Why are platinum, gold and silver are used to make the jewelry? We know that there are varieties of jewelry which are made up of platinum, gold and silver. What is the reason behind it? There are mainly two reasons here. Because these metals are lustrous. Because platinum, gold, silver are lustrous. They have a shiny look, so that they look very beautiful once a design is made out of these metals. These are lustrous. And another one important thing is they are non-corrosive. Means they will not usually react with the external environment. These elements are non-corrosive. They will not react with the external environment like air, water to form any other substance, because of which we will use this in making the jewelry. Next, give an example of a metal which is poor conductor of electricity. We have studied in this session only which is the metal that is poor conductor of electricity. Lead is a poor conductor of electricity, and also mercury. Mercury is also poor conductor of electricity, which is a metal. Then a metal which can be easily cut with a knife. We know that sodium is a metal which can be cut with a knife, and also potassium also, and a non-metal which is liquid at room temperature. That is bromine is liquid at room temperature. Okay. Now let's see how do metals react with water. In the previous case, we have seen that different metals have shown different reactivity towards oxygen. In the same way, here also different metals have different reactivities towards the water. Let's see how does this goes. What happens is usually metals react with water to form metal oxides and hydrogen. Those metal oxides which are soluble in water, they form metal hydroxide and hydrogen. Okay, metals react with water to form metal oxides and hydrogen, and those metal oxides which are soluble in water, they form metal hydroxides. Remember that all the metals will not react with water. All metals will not react with water. Let us see how do metals will react with water by taking examples. Let us first take the example of sodium and potassium. These metals, sodium and potassium, reacts very violently with water, and the heat is liberated during the reaction. It is so much that it causes the hydrogen to catch fire. Okay, when metals like sodium and potassium react with water, they form hydroxides. Along with the formation of products, there is a liberation of large amount of heat here. And also sodium reacts with water violently, resulting in the formation of sodium hydroxide, hydrogen. Along with this, there is a liberation of large amount of heat. Okay, balance the equations. These two reactions are very violent in nature. See here, there is a liberation of heat during the reaction. The liberated heat is so much that it will cause the hydrogen to catch the fire. The reaction is violent. The liberated heat causes the hydrogen to catch fire. What happens here is, if you have taken cold water here, even there is no need of heating the mixture. These two will readily react with the cold water itself to release large amount of heat. And you are going to add sodium or potassium in the cold water. Then the reaction takes place very spontaneously, resulting in the formation of the hydroxide. And there is a formation of bubbles here. These bubbles are of hydrogen. Once this hydrogen is liberated, the reaction mixture where there is more heat is evolved. This causes hydrogen to catch fire. Hydrogen catches fire. And due to the formation of these bubbles, they will stick to the surface of sodium or potassium, and these metals starts floating on the water. And as this hydrogen catches fire, this also causes sodium or potassium metal to catch fires. To catch fire, resulting in the violent reaction. So these two reactions, that is potassium and sodium with water, react very violently with water, resulting in the liberation of large amount of heat. Okay, now let us see how do other metals react with water. Then calcium also react with cold water. It will also react with cold water to form calcium hydroxide. But this reaction is not violent as that of the potassium or sodium. It is less violent. Here also there is liberation of heat, but the heat evolved is not so much to cause hydrogen to catch fire. Here also the calcium starts floating on water as the bubbles of hydrogen gas stick to the surface of calcium metal. Okay. When compared to the sodium and potassium, the reaction of calcium with water is less violent. This calcium also react with cold water only. These three metals, they react with cold water. There is no need of heating the water here. They readily react with water to form the product. Now let us see how do other metals react with water. When it comes to magnesium, this will not react with cold water. It will react with hot water to form hydroxide, and this reaction is also not violent in nature. Magnesium reacts with cold water. Magnesium reacts with hot water. It will not react with cold water to form hydroxide. Then let's see how do other metals react with water. The metals iron, zinc, aluminium, they will not react with either cold water or hot water. They do react with steam to form their respective oxides. Let us see how does the reaction takes place. Iron reacts with steam to form oxide. Okay, this is the oxide of iron oxide, and also aluminium reacts with steam to form its oxide, aluminium oxide. These metals react with steam to form metal oxides. Now you are going to understand why the reaction is not same for all the metals. Different metals show different reactivity towards the water. And what about the other metals like lead, mercury, gold, silver, platinum? These metals do not react with water under any condition. These metals do not react with water. Okay, you have to remember how different metals show different reactivities towards the water. We have seen here that sodium and potassium react very violently with water to form hydroxides and hydrogen gas, and the heat liberated is so much that it will cause the hydrogen to catch fire. And when it comes to calcium, calcium reacts with cold water, but it is not that much violent as that of sodium and potassium. And when it comes to magnesium, it will not react with cold water. It will react with hot water to form magnesium hydroxide and hydrogen. Then the metals like iron, zinc, aluminium, they do not react with either cold water or hot water. They do react with steam to form iron oxide and aluminium oxide, and this reaction is also not that much violent. And you can see here the metals lead, mercury, gold, silver, platinum, they do not react with water under any condition. Okay, how do metals react with water? Let us summarize it in a simple way. The metals potassium, sodium, they react violently. Calcium also react with water, but it is less violent. Then what about magnesium? It will react with hot water to form respective hydroxide. Then what about the metals like iron, zinc, aluminium? These metals will react with steam. Then the metals like mercury, lead, gold, silver, platinum, they do not react with water. So you have to remember the different reactivities of these metals towards the water, where the reaction is more violent, where it is less violent, and what are the products that are formed. Here you can see when the potassium and sodium reacts with water, they form their respective hydroxide. Okay, they form respective hydroxide, and the liberated hydrogen here catches fire. And in case of calcium, it is less violent and it results in the formation of calcium hydroxide, and magnesium forms magnesium hydroxide. And these metals, iron, zinc, aluminium, they form respective oxides, that is iron oxide, aluminium oxide, in this way. And these metals, you should remember that they will not react with water at all. This is all about the reaction of metals with water. You should remember all these facts, where the reaction is more violent, less violent, where they will react with hot water, which metal react with steam. This is all about the reaction of metals with water. Okay, this is all about the today's session. In the next session, we are going to discuss still more properties of metals and non-metals.